Here's experiment 13, aluminum analysis. I'm going to demo trial 1 for you. So here we need approximately 0.03 grams of aluminum metal. So I'll put a weighing tray on and zero it. We'll add a small piece of aluminum. And we will record this as the mass of aluminum sample. It's 0.029 grams. So the aluminum sample will be recorded as 0.029 grams. Okay, I've taken our aluminum metal and cut it up into small pieces to increase the surface area. I'm then going to put those pieces into a small test tube. We're going to take 15 milliliters of hydrochloric acid and add it to the ignition tube. We're using enough hydrochloric acid that will be the excess reactant. So there's more than enough acid. We're going to consume and use up all of the aluminum pieces as the limiting reactant. I'm going to slowly slide the test tube with the aluminum metal into the ignition tube. This way the acid and the aluminum are not in contact until I'm ready to collect the gas. So this reaction is going to produce hydrogen gas, which I need to collect in order to measure its volume. So I'm going to place a stopper onto the ignition tube, tighten and set that there until I'm ready. We're going to record the temperature of the gas collection site. So the temperature of the gas collection site is going to be the same as this water, which is 20.0. So we will record the temperature of the gas collection site as 20.0 degrees Celsius. I have also checked the barometer and the barometric pressure in the room today. The barometric pressure for number 5, we will record as 709.7 torr. 709.7 torr. Now what we're going to do is take a burette. Here's a burette. Make sure that it's in the closed position. I'm going to pour water into the burette up to the 0 mark at the top of the burette. I went a bit past the 0 mark, so I'm going to allow just a little to drain until my meniscus is at the 0 mark. Okay? Now what I'll be doing is putting my finger on top of the burette, turning it over and submerging it into this water bath, letting go of that. We'll place it in the burette clamp, making sure that it stays submerged. And now I'll take this U-tube so that it rests inside of that burette. So what this is allowing to happen is when the hydrogen gas is produced here, it will travel through the tube and it will be collected and trapped over top of the water in the burette. So that's why this is called collecting gas over water. We're collecting it above the water in the burette. We'll see bubbles and it'll push and displace water from the burette. However much water gets displaced will tell us what volume of gas has been produced. So now that we have our setup ready, we're going to take our acid and metal and we're ready for the two to become in contact. So we're going to tip it a couple of times to allow the two to come in contact. Place it back here. Starting to see small fizzing occurring here, bubbles of the hydrogen gas being produced. Soon those will travel through the tube and we'll start seeing bubbles coming up through the burette. So bubbles are traveling up. Hydrogen gas is getting trapped above the water. We want to continue until there's no more bubbles being produced and all of the aluminum has disappeared in the ignition tube, in the large test tube. Once again, the aluminum is our limiting reactant, so it needs to all be consumed. Bubbles are still being produced. The water is being displaced and pushed down the burette. So I'll tilt it one last time to make sure there's no magnesium left in here. Aluminum, sorry. No more aluminum. It has all reacted. I see no more bubbles being produced. So I'm confident that the reaction has stopped. The next step is I will take the burette, I'll clog it with my finger, and I'm going to put it in what's called a leveling tank. What this is going to do is make sure that the pressure inside the burette is equal to the atmospheric pressure pushing on this water. So I'm going to take the burette into the leveling tank. I'll remove the U-tube. So the gas is still trapped here. I'm going to stopper the burette with my finger so that I'm still trapping the gas and water. Here's the current water level. I'm going to place this in the leveling tank and move it until that water level inside the burette is equal to the water level of the leveling tank. So at this position, the atmospheric pressure, which was 709.7 torr, is equal to the pressure inside the burette, which we know is equal to the pressure of the hydrogen gas along with the water vapor pressure. So while it's in that position and the two levels are equal, I'm going to stopper it again. Pull it out. Turn it over. And now I can rest it back into the burette clamp. The gas has now escaped, but what we know is that the water level was up at 0 on the burette. And we will now record the new level of water in the burette. So if it displaced 40 milliliters of water or 20 milliliters of water, that's the volume of the gas that was produced. I will show you a picture of this meniscus so that you can record the volume correctly. Using a burette, you will want to go to 2 decimal places for your volume. And that's because each tick mark is 1/10 of a milliliter. So you'll actually want to go to 100. So you'll want to use 2 decimal places. And I will zoom in and take a picture for you of that meniscus. That will give you the volume of the hydrogen gas produced.